There have been a lot of videos on Instagram and different reels where people create magnificent portraits or images by using dice. So I thought I created a video on Blender on how you can model a dice. The link is over here, but why not create entire portraits using dice itself procedurally so that if you don't have the time or the talent necessary to do these artistic works, maybe you could have Blender figure everything out for you. And if you want, you could always just arrange them in the exact same way in real life to get the images. So let's find out how you can do this in Blender. Of course, if you are already using the dice from my previous tutorial, you can do that. But in today's tutorial, I'll just teach you how to go through a very simple dice. So first you press tab to go into edit mode. You can always use this drop down over here and then go to the face select mode over here. After which, make sure everything is selected by tapping A and then press Ctrl E. Now in this menu, click subdivide and then expand this button over here and just increase the number of cuts to 2. Then you can always bring this back down. Now this is a much simpler version of the dice, but it'll work for what we want to do. So on the top face, we'll select the central one and then we rotate to the front face and press shift and select these 2. Then we turn again and select these 3. Then we turn and select these 4. And lastly, we select all 5 with the final face at the bottom where we select 6. Once you've selected all of these faces, you have to press I twice to inset along individual faces and just bring it down by a little bit, after which you can press Alt E and choose extrude faces along normal. Now you can just bring it in, you could bring it out if you want, but I'm going to be bringing it in by just a little bit, nothing too fancy. And once I'm happy with the amount that I'm bringing it in with, I'm going to have to press Ctrl numpad plus to expand the selection by 1. In case you don't have a numpad, you can always go to select more and choose this more button over here. That way even these inner walls are also selected, and then you can go to the material properties over here, press this plus to create a new material slot and then press new to create a new material. We'll call this dots and we'll hit assign. Along with that, we'll change the material to dice. So that way dice is the body and dots is the dots. Now you can press tab to go back into object mode, and we actually have to do a little bit more modeling just to make this a bit smoother. Now we'll go to the modifier properties, add in a bevel modifier just to round up the edges, and then we'll go ahead and add in a subdivision surface modifier to make these squares more or less circular. If you actually increase the levels, you'll see that they become even more circular, which is exactly what we want for a dice. But essentially we're going to increase it for the render, maybe up to 3 or 4, but for the views we'll keep it down at 1 because it will be very laggy otherwise. Along with that, we just go to the object tab over here and click shade smooth so that it becomes nice and smooth about the edges. Right now it looks jagged, but when you increase the levels on the subdivision surface, it will become really nice later on. Next up, we're going to use geometry nodes to create the array of cubes or dice and rotate them as well. So we'll bring our cursor to the junction of these 2 windows, click and drag to create a new window, and we'll use this cube itself as the geometry node object. So we'll switch from the 3D viewport to the geometry node editor. Now we'll press the plus button to create a new node tree, and we actually need the group input because that is our dice. But we don't need it to be connected to the group output directly, so we can just remove this connection. And if you have Node Wrangler switched on, you can always use Control right click to click and drag to cut selections. Now what do we need? We need a grid to distribute these cubes onto. So we'll press Shift A and search for a grid node and plug that into the geometry. Now I want it to be fairly large. I'll make it 5 units on each of the axes. So I'll shift select both of them and press 5, and that makes a 5 by 5 grid. But I need to play with the number of vertices because that's going to be the number of dice that there actually is. So maybe I'll go with 50 by 50 for the tutorial. However, I generally go with 100 by 100 to get a really nice resolution. Remember, the larger this number is, the better will be the resolution, but of course the longer it'll take for Blender to calculate. So next up, we actually have to instance the cubes onto each of the points that we just created. I'll press Shift and search for an instance on points node and plug that in. For the instance, I can use my cube, but of course the cubes are way too large. So I'll go to the scale over here and just scale them down till they become nice and snug. This seems a little too small, so I'll make it 0.048, and that seems nice enough for what I want to do. So this is my grid of cubes. So now we have to find a way to play around with the rotation such that the cubes rotate based on an image that is given. So the first thing that we have to do is figure out what rotation corresponds to which number. Remember, the smaller the number, essentially the lighter the cube is going to be if you keep the dots as black and the cube as white. But if you keep the cube as black and the dots as white, then the lower the number, the darker is the outcome. So before I actually add in the image and play around with the rotations, I'll just give them the material so that we can actually see the changes even better. So I'll change my viewport import shading to render, and then I'll go to my materials, and for the dice, I'll initially make the dice white and the dots black, but maybe I'll show you a version where the dots are white and the dice is black as well. Now, I don't want there to be too much of specular reflections happening off of these black dots, so I'll go ahead and just make them metallic and completely rough as well, and that will make the black a solid black. Along with that, I don't need this light, so I'll press delete to remove the light, and for the background over here, I'll just go ahead and increase it all the way to white. Similarly, I just want some ambient occlusion so that you can tell the difference between the different cubes. So I'll go to my render properties, switch on ambient occlusion, and now you can actually see the borders between the cubes, which looks really nice in my opinion. Now let's select the cube again and add in the image texture that we're going to be doing. So I'll press Shift A and search for an image texture, and I have to actually open it up. So I'll press this button and select the image. In this case, I've used the image of a rose. Now to actually see the image, what you can do is use a viewer node. So just search for a viewer node, and for the geometry, we'll plug in the grid directly and we'll use this color into the value. So now if you actually press this button to make it visible, you can actually see what's being seen at the moment. And clearly there's something that's seen, but it's repeated multiple times. So the first thing that we want to do is switch it from repeat to clip. Now there's only one image that's formed. Now if you want even more resolution on this image to see it better, you can increase the vertices from 50 to 100, and that way you see it starts becoming more easily visible. So we can increase it even higher, make it maybe 500, and you can see this is the image that we are actually going to be creating. However, I don't require this much of resolution for the dice as well, so I'm going to keep this back down to 100 itself, and I just want to make sure that this particular image fills the entire size of the cube. To do that, in this image texture we have this vector input. So I press Shift and search for a position node, and I plug that in, and then we can use some vector math to manipulate it. So I'll press Shift and search for a vector math node, and we'll keep the last one as add, which helps us move it on the X and Y axes. If I move this on the X axis, you can see how it's moving. If I move it on the Y axis, you can see that it moves on the X and Y axes. So to centralize it, both of them have to be 0.5, and that way the image comes to the center. Then there's two more multiplication nodes that I want. So the first one is going to be a vector math changed from add to multiply, and this one is essentially going to be used to scale the entire image. So I'll keep all of this at 1, and then I'll duplicate this multiply node, and this one should be for the aspect ratio. Essentially, if you have an image that's not a square, so right now I've opened one image that is not in a square aspect ratio, and you can see that it's clearly getting squashed on the y-axis. So the first thing that you have to do is actually find out what the aspect ratio of this image is. So you can go to where it's stored in your file manager, and then you can right click it and press properties, and under the details you should be able to see what the dimensions are. So in this case it is 1120 into 1920. So essentially you have to divide these two and you'll get a number, and that number you have to add into that multiply node. So let's divide 1920 by 1120. So 1920 by 1120 is 1.714. So in this first multiply node, since it's vertical, it has to scale up on the y-axis, which means you have to multiply it by a higher number on the x-axis. So 1.714 I think was the number that we got, and that way you can see how it fits into the actual aspect ratio that it was. Then the second multiply node is what's going to help make it fit the entire region. So here I can just take these two and start bringing them down, and you can see it fits the entire image like that. So that way this one controls the aspect ratio, so you just divide the pixel size x by y or y by x and then plug that in over here. And for this multiply node, you can bring both the x and the y down together to increase the size, and this add node is to shift it on the x and y axis. So this is a nice setup to use any aspect ratioed image to get it to work fine. But now I don't want this particular image, I want the rows that I was using, so I'll change it again. And because this one is actually in the square ratio, I have to change this back down to 1, and now we get the square rows. Now remember, the actual image that we're using is a colored image, but we're just going to get black and white because this is a gray dot, which means it takes in only float values, and hence only the lightness value from this color output is going to actually affect this node. And that's actually what we need, because all the comparisons that we're going to do is going to be based on the lightness value itself. So I'll take this viewer node and press X to delete it, and now we can just zoom in quite a bit and switch off overlays. Now you see this is seeming wrong, and that's because we increased the vertices to 100 but we actually scaled them for 50. So I'll just change this back to 50, and now we have our dice back again. Now how do we rotate them? So first I'll press Shift A and search for a compare node, and I actually want to compare this image texture and see whether the value is less than 10 divided by 6. So 10 divided by 6, you can round it off to something like 1.6, and that's what we're going to be using. Now, if it is less than 1.6, I want it to actually be 6, but since I'm going from 1 to 6, I'll actually change this to greater than, and I will change this to 10 minus 1.6. And this value I can actually plug into a mix node. So I press Shift and search for a mix node, and I have to change this from float to vector because the rotation is going to be a vector. Now this result is going to be the factor, which means if it is true, it's going to take socket A, and if it's false, it's going to take socket B. Now, if it's true, it's greater than 8.4. I want it to be very bright, and the brightest we can get is the 1 on top, and for that we don't need any rotation, so we keep this at 0, 0, 0. But if it's less than 8.4, I want it to go to 2, and for 2 we have to see what rotation corresponds to 2. So first let's rotate it on the x-axis by 90, and we see a rotation on the x-axis by 90 corresponds to 3, so we don't want that. Let's try minus 90, and that corresponds to 5, so that's not going to be right either. So I'll make this back to 0 and then rotate it on the y by 90 degrees. Now that corresponds to 4, so I have to try minus 90, and minus 90 corresponds to 2. So that means if it's less than 8.4, I'm going to change this to have a rotation on the y-axis by minus 90 degrees. Next, I want to see if it is lesser than 8.4 minus another 1.6. So I'll take this greater than node, press Shift D to create a duplicate, then take this color value and plug that into the socket over here, and I'll just bring this to the side. Now remember, this image texture is actually giving a value between 0 to 1, but I'm just taking it between 0 to 10 because I'll add in a map range node a bit later. So now this 8.4 minus another 1.6, and if it is greater than 6.8, we're already getting this over here. So in this case, it has to be less than. If it's less than 6.8, we're gonna have to use the next rotation. So I'll take this mix node, press Shift D and duplicate it. Now the result of this is gonna go into the first socket of the next mix node, and the result of this is going to go into the factor. Now, if it is less than 6.8, it has to go to 3. So we have to see which rotation corresponds to 3. Now, as far as I remember, 3 corresponded to a rotation on the x-axis by 90 degrees. So that is what we're going to use, which means the second vector over here has to be 0 on the y-axis and 90 over here. Now we're going to do the exact same thing again. Take this less than node, press Shift D to duplicate it, and we're going to change this from 6.8 minus another 1.6. Get this color and plug it into the first socket. Take this mix node, press Shift D to duplicate it. Take the result, plug it into the factor. Take this result from the second mix node and plug it into the first socket of the third mix node. And now we have to make the rotation equal to the fourth one. So 4 was 0 here and 90 here. So that means y-axis has to be rotated by 90 degrees. So make this 0, make this 90, and that's 4. Now for 5, I'm going to actually use slightly more than 1.6. So I'll take this, press Shift D and bring it down here. Bring this into the first socket. Change this to 5.2 minus 1.8 because this 1.8 will take care of the rounding error that we had, because 10 divided by 6 is not 1.6, but it's a little bit more than 1.6. Now we take this mix, press Shift D and bring it out here. Take this result and plug it into A, and the result from this less than is going to go into the factor, and now we need this to be 5. So as far as I remember, 5 was, I think, minus 90 on the x-axis. Yes, it was minus 90 on the x-axis. So change this to 0 and make this minus 90. Then lastly, if it is even lesser than 3.4 minus 1.6, so press Shift D, change this to 3.4 minus 1.6, which is another 1.8. We can take this, bring it into this. Now this shouldn't have been 3.6, it should have been 3.4 minus 1.6. Okay, and so 1.8. So if it's less than 1.8, it has to rotate by 180 degrees on either the x or the y. It will be the exact same outcome to get to the opposite side, which is the 6. So I'll plug this result into the factor, this result into socket A, and here make this 180 degrees. Now this result has to go into the rotation of the instance on points node. But before I actually put it into the rotation, I want to actually map range all of these. So if you have Node Wrangler switched on, press Shift, right click, and drag it across all of these to create a junction. And now you can just place one single node before that. So I'll press Shift A and search for a map range node, plug that in, and I'm going to change it from 0 to 1 to 0 to 10. So that way everything gets multiplied to 10. And this works out perfectly, and we can directly plug this into the rotation. However, remember, this we've calculated in degrees, that's why we've used 180, but this socket, if we plug it from the outside, is going to take radians. So we have to convert the radians to degrees. So remember, pi radians is equal to 180 degrees. So we can search for a vector math node, change it from add to scale because we want to change it on all of the different axes by the same amount. And because pi radians is equal to 180 degrees, we have to actually multiply this by a value of pi divided by 100 180. So that value is going to convert it from radians to degrees. So I can plug this result into the vector and this vector into the rotation of the instance on points. And that way everything should rotate accordingly and you should be able to get the image right over there. If you zoom out enough, this is your rose image. Now you can always zoom in, get your camera, and then just create a small animation going through the dice and everything. But I think it actually looks much better if you use the dice as a dark color and have the dots as a brighter color. So for that, I'll go to the materials, go to the dice, and just change the base color down to black. And of course, to make it actual black, I'll increase the metallic all the way to 1 and increase the roughness all the way to 1 as well. Then I'll go to my dots and just go down to the emission and make this all the way to white, and that way you get it nice and white and you get your rose image over here as well. Beyond that, since you're inverting this, you can always invert these by changing this greater than into a less than and starting with the lowest value of 1.8 and then slowly increasing and changing all of these values to go to a higher number. So that would actually be less than 1.6, and all of these would become greater than 3.2, greater than 3.2 plus 1.6, which is 4.8, and then again greater than 4.8 plus 1.8, which is 6.6, and the last one is going to be greater than 8.4. So that way you'd get another image as well. Now if you want the image to have even more resolution, you can always go ahead and just increase the vertices. Maybe we'll make it 100. But remember, when you do this, you have to go back to your instance on points node and change these values over here. So in this case, since I increased it by 2, I'm going to have to divide this by 2. So I can just take this, type the same number itself, so 0.048 divided by 2, and that way you'll get your actual dice back and the image has a much greater resolution as well. So that's actually all there is to it. Of course, you can animate the camera however you please, but I'm not going to go into the animation of the camera in this particular video to keep it a bit shorter. And there are hundreds of videos on my channel that explain how you can animate a camera around a situation like this. In fact, if you want to learn something cool, you can definitely check out this video in the top right corner where we convert any image into circles in geometry nodes itself, and we move the camera around in that video as well. So with that, you can always set up your defaults and click render animation, or you can actually just buy yourselves as many dice as required. So in this case, we went with 100 into 100, which is 10,000 dice. And you can just see that, okay, the first dice has to have 2 up, 2 up, 2 up, and just go and place all of them one by one to form whoever your favorite celebrity is. Or if you want to gift this to someone and they really like something, you can always go ahead and just place this and they're going to think you have a lot of artistic skills. Little will they know that you actually just figured out where to place which dice using Blender. Hopefully this video was useful to a lot of you and you'll be able to create either good content or just amazing videos using this concept. I post videos every single day with different techniques that are used in Blender, so I'm sure you'll come across something or the other that will genuinely help you. So do check out other videos on my channel because that'll help me out quite a bit. Until the next video comes out tomorrow, keep creating and stay creative.